Merci Olivier, merci tout le monde. Je sais qu'il y a certains d'entre vous qui maîtrisent pas le français. Je vais probablement parler beaucoup anglais, mais mes slides sont en français, donc ça va faire un mélange. N'hésitez pas si vous avez des questions dans votre langue, j'ai pas de problème avec ça. Puis si vous avez des petites questions de compréhension pendant la présentation, vous pouvez faire signe aussi. Je peux la répondre tout de suite plutôt qu'attendre à la fin. Pour les questions plus larges, on pourra le faire à la fin. Ah, Yannick. So, as I just said, I'll do probably most of the presentation in English so that everybody can understand, but the slides are in French and I can switch to French anytime to explain something. And you can like ask questions in any of the languages that you wish, and I'll adapt. And if you have very quick questions, understanding questions, you can ask them already. For more general ones, we'll wait until the end. So, yeah, today I will very, very quickly go through what I did and where I come from and what I'm doing right now as a researcher. Then I will give some general idea of what is measuring the impact of human activities on climate change. So on what am I working in my research? And I will spend like some time showing 3 examples of research projects that we're working on. And since, of course, it's a GERAD seminar, I'll make like links on how different research in terms of advanced modeling, mathematics, artificial intelligence, and so on could help this type of research. So very quickly, so I'm a graduate from Polytechnic in chemical engineering 24 years ago. Then I worked for 8 years in the industry, an oil refinery, which is quite far from what I'm doing right now, as you can see. So after these 8 years, I decided to really orientate my career to the academics and also working on the environment. During my undergraduate studies, I had a concentration in environment, so I wanted to really focus on that for the rest of my career. So I went back to Polytechnic to do a PhD. Still in the chemical engineering department, most specifically on life cycle analysis, which is a methodology to account for environmental impacts. And I'll talk a little bit more later on this. Then I stayed there as a research associate, then a researcher for a few years. And then I went to École de technologie supérieure in 2017 as a professor. And so I'm there since the last 6 years. So as Olivier said, I have a Canada Research Share. I began that in 2020. So really the mission of this is to work on like measuring tools. And the idea is really to help put in place climate change action plans. So we need numbers. So we need to quantify things in order to understand what we should do and what's the impact of what we do. So that's really like the main idea of my research. And of course, for that, we need data and new sources of data and modeling. And all these models, and you will understand, I will show very good example of that, are coming from very different disciplines. So I work with a lot of researchers from different departments, different universities, like a researcher who's trying to do that and who works just by himself or herself in the office is not really good because you cannot know everything about what you're trying to model. And finally, of course, we can look at all these questions on different scales. So the product scale, urban scale, national scales. So you'll see different examples of that. And it's quite complex questions, quite complex phenomenon that we try to model. So that's why we could be helped by like experts in the fields of mathematics, modeling, big data, and so on. So that's the point I'll try to make. Very quickly, also, as Olivier said, I'm the scientific director of 2 research centers. The first one is the CERIEC on the circular economy. It has been created in 2020 at ETS. So this is my team. So I'm the scientific director. So more working on the strategic and scientific orientation. And all these great people work a lot on, for instance, acceleration living labs on the circular economy and different things like that. So we have like a group of 40 researchers at ETS. And through those living labs, in fact, we are doing research with many people from different universities as well, not just ETS. And the second institute is something that we just created last year. It's because it's the result of a huge proposal that we've developed for the CFREF program, which is a national research program. We have not been funded, unfortunately, but we've decided that this was very important. So the mission is really to work on the adaptation of our built environment to climate change. So it's, once again, multidisciplinary. This is a very small team we have right now because we are actively working on finding alternative sources of funding so that we can fund all the activities that we wish to put in place. And all the universities are invited to be part of this. We already have several of the universities in Quebec and Canada, and like everybody is really welcome. It's a kind of one-stop shop that we want for all the Canadian community and not just ETS-based initiative. So that's what we're doing right now. So I'll go in the research for the moment. So of course, like everything that I'm doing is, yes, about environmental impacts in general, and also focusing on climate change. So probably that I won't you won't learn anything if I'm telling you that we have an issue with increasing temperature right now. So these are observed temperature that we see. So this trend since the beginning and even most from mid of the last century is really an issue. And of course, all the research that has been done in the field have shown that most of this warming is really due to human activities. So you can see on the right, it's greenhouse gases that is mainly the cause of global warming. So we emit these greenhouse gases, but also other types of drivers. There are other human drivers, and I'll discuss very quickly about it. But most of the quantification that we're doing right now is around GHGs, because that's the easiest part, but we try also to model other forces. So that's just a quick overview of what is the issue right now. So this is the natural carbon balance. So what we do, of course, you can add to this other GHG that are man-made, such as halocarbons and so on. But these are yes, they are important, but it's a very small part. Everything else is mostly related to the carbon cycle. So what we do right now, basically with human activities, is that we accelerate the emission of the carbon contained in the fossil fuel to the atmosphere. So that's a huge part of it. But we also impact the biogenic carbon, which is part of the vegetation, and which is what we call the short-term carbon cycle. So we impact this also. A very simple example is what we do with tropical forests, the Amazonian forest, for instance. We just cut wood and we don't let it regrow, but we can do this at a lower scale, also just managing the forest. So this is also something that is a human driver. And while doing this, when we change land use, we also affect albedo, for instance, which is the reflection of the energy from the sun. So that's something that we can try also. I have a PhD student working on this, how we can account for GHGs, for instance, when we use wood, but also from affecting the albedo of the land. Of course, then the IPCC shows the different pathways that we should follow in order to try to keep the temperature increase lower than 1.5 or 2 degrees Celsius, and that led to the establishment of different GHG emission reduction targets at the different levels. So you see them at the national, provincial, city levels, and the idea of basically the tools that we develop in our research team is to help these decision makers understand where are the main emissions and how we can decrease them so that we reach these targets in order to allow us reaching our goals. So this is an example. I will have how we do for Canada, for Quebec, and for the city of Montreal. And these are what we call territorial inventories. I'll talk a little bit more later about this. But for instance, the blue line is like the national curve of emissions. So we can see, and on the right side, I just have the different targets that we have. But as you see, as we all know, we're not really close to the different pathways that we should follow. So how can we help these governments identify how we could do this? The provincial level, it's the same. So this is not the total, this is per sector. But as you can see, most of them are quite stable or increased. This one is the transport sector, so we are increasing. The one that has decreased is more the industry because of the carbon market we have in Quebec. So we observed a certain decrease there since the beginning of the carbon market, but others, the trend is not really decreasing, and we're not close yet to our different targets. So this is something, especially on transport, this is something we work a lot, try to model the impact of transport and identify the best strategies. And this is like the same example, but at the level of the city of Montreal. And there are different challenges associated with modeling that for a city. I will talk about it when I will show an example of research project that we do at the urban scale. So in order to help like municipal decision makers identify how they could reach their targets at the city level. So as you can see, once again, like we have a kind of decrease since 1990, but quite stable. And you can see, of course, the pandemic in 2020 that has led to a decrease because the economy was running low. We stayed home, so no transportation basically. But what we see with 2021 and what we expect with 2022 is that it's going back up because we're just doing as normal now. So in order to help decision makers, and decision makers can be at the government level, they can be within the different industry, they can be consumers, but in order to help all these people make the better choice, of course, we really need quantification tools. That's very important first to make sure that we allocate the resources that we have at the right place. So where is it more efficient to put efforts? This is an example where maybe it's not the right place. It's not that it's not good to just remove the straws from the cafeteria, but that may be not the first thing to do. But we can have plenty of examples like that. If you don't quantify, you just like rely on very subjective ideas and you might not do the right thing. So to do this, and this is a challenge in all these research, is really to find the right data. And if you don't have it, like to model, and it's always very complex systems that we try to model. So some parts are not so complicated, are quite straightforward, but other parts are quite complicated, as you will see in the different examples that I show. So there are different levels of carbon accounting. And all these levels are some parts in common, but also have their own challenges. So, and as I said earlier, something that is very important is to think about the life cycle of the different things that we do, that we consume and so on. So life cycle assessment itself is a methodology for which we really focus on the life cycle of a given product or service. So that's one of the level of accounting, but we know that let's keep Montreal as our territory. So we know that when we have some of the life cycle phases that are occurring, of course, in Montreal. So let's say that I don't know, of course there are some plans, so maybe that I consume a good that has really been fabricated in Montreal, but in many other cases, no. The upstream of the value chain is elsewhere. And also maybe that I produce things in Montreal, but they are used elsewhere, they are thrown away elsewhere. So these activities can occur at different places. So I'll base on this figure in order to explain the different types of accounting that we work on. Of course, you have this territory, which is Montreal, and you have many activities. People are living there. You have production, and so on. So you have very different activities. So as I said, the first level is the life cycle one. So when we do that, we take one product. Let's say that I want to do the life cycle assessment of this computer, and I will really think about everything that is occurring upstream. So all the raw materials that are extracted, the different production activities, transportation, distribution, storage, then the use, as I use electricity. And then when I'll throw it away at the end of life, do I recycle some parts? Do I just send it to a landfill and so on? So we want to take all this into account. And this type of methodology is framed by an ISO standard. And basically, we use that to orientate, of course, consumer choices. For instance, the design of products or project when like a company wants to decrease the footprint of what they put on the market, they're going to use this type of assessment. Some kind of legislation also, just to give an idea at the federal level, we have a new, it's a low carbon fuel standard. So in order to, and like they will require that all the fuel sold in Canada, the carbon footprint will have to decrease over time. But in order to understand if we reach or not this target, of course, we need life cycle assessment to calculate the carbon footprint of all the different fuels that are sold. So it's really used, they really built a life cycle assessment tool in order to implement that regulation. Some strategic orientations also. So it's more and more used, the life cycle assessment, and it's a lot of data. Of course, you can think about everything that, for instance, this computer, everything that is included in the life cycle. So it's already a lot of data, but the boundaries are quite simple for this case. You can also see carbon footprint at the organization level. So for instance, an industry or a school like ETS, they did their carbon footprint. So the boundaries are different. It's the same kind of data that you need, but the boundaries are different. And you might have already heard that scope 1, 2, and 3 language. So that's coming from that type of assessment. Scope 1 is the direct emissions. So let's say that I'm a university. So if I have emissions because I heat the building with natural gas, then this will be scope 1 emissions. If the university owns a truck to do different things, the fuel consumed by the truck is scope 1. Est-ce que je suis encore connectée? J'ai l'impression que mon Zoom se déconnecte. Je suis connectée, c'est bon. Là, je suis déconnectée. Ah, c'est ça. Okay. So yeah, I was saying that scope 3 emissions, it's all the other indirect emissions. So for instance, if we have like everything that we buy and so on, they are scope 3 emissions. So these are for the organization. What we also have the territorial level. This is what governments use. All the numbers that I've shown for the federal, provincial, and urban scale were really territorial. So they account for everything that occur on the territory, everything that is upstream. Even if we consume the good here, we won't take into account for the production. They do this because they say that's what we have power on, but in fact, we also have like leverages in order to decrease what we consume, even if the emissions occur elsewhere, because we can decide to consume differently, or like to keep the goods for a longer time, or to not always buy new goods, but to buy used goods. So we have a kind of leverage on this. So that's why we also have what we call the consumer level. So at the consumer level, we're trying to look at like someone living in the city, and what is his footprint. So it's the life cycle carbon footprint of everything that he consumes. So that and we don't care if it's occurring in Montreal, if it's occurring outside. If he consumes it, it's because he's responsible for it. So those two levels, the territorial and the consumer, or the consummation level, are very important in order to orientate policies. Unfortunately, for the moment, governments look a lot at the territorial level because all the international agreements such as Kyoto and Paris Agreement are based on territorial level. If everybody works with the territorial level, it could work, but of course there are some limitations. But we see more and more results of study at the consumer level because it can be very useful. So of course, to do all these type of accounting, we need a lot of data, three main types of data. So the first one is we need indicators in order to see what the impact of an emission of pollutant. These indicators come basically from the natural sciences, environmental models. So we don't work a lot with that. We use those that exist most of the time because we're not in that field. But then we really need the other two in the types of work that we do. So first, we need to be able to understand what is the amount of pollution or the amount of carbon emitted by one single activity. So we have to do that, for instance, life cycle database, statistics, literature, measures, and so on. And for the other one, it's how many of the activity we have, depending on the level of accounting that we do. So it's highly variable, and I will show examples. But if I do a territorial accounting assessment, it's not the same as if I do a life cycle assessment. And even if I'm at the territorial assessment, if I'm at the federal scale, I don't have the same challenges that if I'm at the urban scale, because the data available is not necessarily at the scale that I need. So I have a lot of challenges associated with that. And of course, the different types of challenges, of course, it's availability of data. So we face a lot of missing data. Some, the processes that we want to model are from very different nature. So that's a challenge. There's a lot of variability associated with geography, time, technology, and so on. So data coming from another country might not be good for my case, and so on. So of course, there are many, many challenges associated with that. So I'll go more focusing on some of the research projects that we work on. So the first one, and Hamed, which is here, will recognize what I'll show because it's basically it's PhD mixed with the research from other researchers. So an example of questions that policymakers want to answer is, what's the role of the forest sector in climate change mitigation? And in Canada, we know that it's a very important sector. And because most of the forest is public, these questions are really in people's mind at the provincial government, because they want to know how to do things better in order to help that the forest mitigation potential. So if having this in mind, we have to think about what's the impact of forest products in general. So we have to think about, of course, about the life cycle. So we know we have a forest at the beginning. We're going to harvest some wood, and trees are going to grow back. Well, in Quebec, that's the case because we have a kind of sustainable management of the forest. So trees are growing back. And then we are going to cut these trees. We are going, of course, to transform them into different kinds of wood products. We also might have some bioenergy from that, especially at the sawmill. We have residues, for instance. And then we are going to, let's say, burn all this at the end of life. We'll have, of course, different fossil fuel emissions throughout these activities. Because we are going to burn fuel in machinery, or we are going to use trucks to transport these Good. And we also have emissions of what we call biogenic carbon. You can see in green, because when you burn the wood, then it's biogenic carbon that you send to the atmosphere. And of course, this carbon is going to be sequestered by the trees. And in addition, you have to think that if we do this, if we encourage this, we might substitute the use of fossil fuels, for instance, for the energy, or the use of materials that are made, let's say, from steel, from concrete, and that might emit more GHGs than this life cycle. So when we think about this at the policymaker level, they want to know, okay, if I harvest more forest, I'm going to affect the carbon balance in the forest. So, and then I'm going to increase GHG emission associated with the value chain of the products. But I'm going also to substitute for more GHG intensive products. So how can I take this into account? So that's all the questions. Of course, first, as I said, and it's an example where we need expertise from different disciplines. We want to model the carbon in the forest. So it's more with forestry people, biology, and so on. So we have models of the forest, of the carbon itself, and we can model different scenarios. For instance, what if I manage the forest this way? What if I harvest more or I harvest less? So I will see the impact on the carbon. So it means it's emissions or sequestration that I will have when I affect the carbon balance of the forest. So we can quantify that. But then, of course, if I harvest more or less, I will have more or less wood that will come out from the forest. So then I can combine that with LCA data. So what's the impact of harvesting this wood in terms of fossil fuel emissions? And as I said earlier, there's this substitution effect that we want to take into account also. So yes, I'm going to have more GHG emission because I harvest more wood, but I'm going, let's say, to substitute more steel and concrete. So I want to take this into account. This is also a life cycle assessment thing. So this is an example of one of the students in the group who developed what we call substitution factors. So we can say to the government, okay, this is the impact on forests of what you want to do, but this is the impact in terms of life cycle emissions for the wood and for what is going to be substituted. So these two steps led to what we call substitution factors. This is really coming from this student's work. So it's the ton of carbon that is avoided by what is substituted per ton of carbon contained in the wood that we are going to use. And of course, depending on what we do with the wood, it's highly variable. So he based this study on different life cycle assessment that he found in the literature or at different sources of information. And this is by itself work still going on because you have different applications, different types of products, and all these factors will vary. So there's a need to really build this type of data. And then he didn't do the other part because it was a master project and that was enough for him. But what we could do then is really take into account, because yes, you know what's the substitution factor if you build a house or if you use the wood to do this type of application of this type of application. But when the government looks at the entire forest sector, where is the wood going? So you need economic-based data in order to understand what's the market. So where is the wood going? What is it going to really substitute? So is it so you have market effects here? So if I put more wood on the market, am I going to decrease the steel market or the concrete market? So I can do assumptions. This is based on assumptions. In this case, that's the result. In this case, that's the result. But when the government wants to look at the impact of harvesting more wood and putting more wood on the market, what is it going to substitute? So this has not been done yet, but this has to be combined to that. So here you have more economic data. And we also need to understand the future, because of course, and I can show back the, this, when you change the way you manage the forest, it takes a lot of time. You see these curves are going until 2100. But of course, this is for current data. But like in 20 years and 30 years, everything is trying to decarbonize. So the life cycle emissions of steel or concrete in the future won't be the same as it is now. But that's the assumption we make right now. So just to give an idea of limitations here, of course, we have simplistic assumptions on the substitution effect, because in this case, we don't integrate yet these market effects. So economic models could be good to do that. As I said, we don't consider the market effects, the future evolution of these emissions, because everybody is going to decarbonize, and I don't have the crystal ball to really know what is going to happen. So probably we would have to look at this through scenarios. And of course, the forest carbon model itself has limitations. So in this field, also my colleagues in forestry really work in order to improve these models. For instance, the carbon in the soil, it's not so easy to model and so on. So these are improvements that are going on there. An example of work that we've done in order to look also at another aspect of this forest sector issue is just move that. Is the use of a techno-economic model such as NATEM. So it's a times-based model. So it's a partial equilibrium model of the energy system, very detailed one. So we use that in order to look at how forest bioenergy could play a role in the decarbonization of the province. So to give an idea, so this is basically what Hamed do in his PhD. So he really found data, techno-economic data about the different bioenergy pathways for the forest sector. You don't have to see everything. It's just to give an idea of the complexity of what it is. So in order to feed the model with that, because for the moment, like at the beginning, there were very few technologies about that. And then he looked at different scenarios in order to understand what would be the market penetration of the different bioenergy, forest bioenergy, with the GHG emission reduction targets that the province has. So to see which one would be the most promising. And when he did this at the beginning, well, biogenic carbon was not included. So it was just the fossil emissions. So then as a second step, he combined the biogenic carbon using the forest carbon model that I showed. So he integrated that into NATEM. And I won't go into details in all these results. The publications are there if you'd like to consult them, because it could take a long time. But the idea is really to show that we wouldn't make the same decisions, taking into account biogenic carbon compared with its exclusion, because we saw different effects. Because just to give an idea, but if you make more bioenergy, you're going to release the carbon right now. But the forest sequestration will take some time, because especially in Quebec, it can take 7 years for a tree to grow. So maybe that you are having more emission right now and just delaying the sequestration. So you won't see this if you don't include that in the model. So that's just an example, but there are other findings that we've made with that. So the limitation of that approach, forest products that are not energy-based are not included. That's something that we could do, add materials to this techno-economic model in order to see also, because when you want to look at what could be substituted, this type of model could really help you. We also have a temporal cutoff with that. So you can, of course, the model, it's an optimization model, so we could easily just postpone some emissions beyond the time horizon. And if you just cut off at 2050, for instance, you won't see it, but that's something that should be considered. Another example is that it does not include the evolution of natural disturbances such as forest fires. We saw this summer that they tend to increase with climate change. That's something else, and I have colleagues in forestry that try to add that into their scenarios. And like with this type of model, which is a partial equilibrium model, then we don't take into account the interactions with the other sectors. So another example would be to combine this with a general equilibrium model, for instance, or to expand the numbers of sectors in the model. So this was an example. I'll go to another example, which is to look at how we can improve the urban scale GHG emissions. It's a project that we called the carbon map that we just began to work on recently. So this is the Montreal inventory that I shown at the beginning. So how it's done right now, basically, it's a mix of what we call activity data and emission factors. So activity data, I'll give the example of transportation. So you can have like top-down or bottom-up approach, but what was used in Montreal was a top-down approach. So we're looking at fuel sales during the year, and it's quite straightforward to transform fuel into CO2, so that's good. That's not too complicated. But with these fuel sales, there are some limitations. First, you don't have fuel sales for the city. You don't just have the data. So you look at fuel sales at the national level or at the provincial level. You scale it down to the city using the number of vehicles that are licensed in Montreal. But there are limitations to that because a car owned by someone in Montreal might not travel the same numbers of kilometers as a car owned in another city or in rural areas, for instance. You don't know if people are really driving in Montreal or going elsewhere. And the opposite, all the people living in the suburbs coming to Montreal. So you don't really know who is using that and where these emissions are occurring. So when you want to scale down at a smaller level, it's more difficult. So that's why there are limitations associated with that. And because it's like one yearly emission, you don't know what is really contributing to that. So it's just total amount of fuel. But what if I implement more bike infrastructure in that area of the city? I don't have the resolution in order to try to understand what would be the impact of this type. So there are also some bottom-up approaches that could rely on the number of vehicles, kilometers in the street. So that's the basis. This type of data is the basis to go to more detailed inventories in order to help decision makers. So I'll go a little bit faster. So the idea, so as I said, there are some limitations to have this annual aggregated inventory. So it's, okay, you can follow up year after year, like is it decreasing or not? But then it's not very, very useful for decision makers. And it's also not very useful in order to make citizens understand what's the impact of what they are doing and how they can make different choices and what would be the impact of that. Because that's also one objective of our research, to really, that our tools are used for instance, citizen mobilization and so on. So what we're doing with that project is, as an example, on road transportation, you have plenty of different sources of data that are there, but we need to understand how we can use them. We have origin destination surveys that can be used in some traffic models. So they are software. If you tell them where people are, where they're going, they have the map of the city and all the different parameters. So they can really optimize all these trips and give you an idea of where, how many cars there are, where. So we can start from that and try to quantify GHG emissions. We could use telematic data. They are quite expensive right now. They are owned by private enterprise. So for the moment, it's quite limited what we can do with that. But in the future, that's something that could be very useful. We have also traffic cameras, traffic compteur, and so on. So that's an example of, like, there's a student right now working on that. She's using the origin destination into this traffic model, but it's just one day in the year. So she's trying to find ways to extrapolate this data to other days of the year and other moments of the day also, because it's just the rush hours, basically. So she's looking at how she can use, for instance, traffic cameras and with some statistic approach, develop some trends from these cameras and try to apply those trends on the model that she already has so that we see the evolution over time. So that's a quick example of this carbon map project. So what the types of limitations that we face, of course, data, it's quite heterogeneous. So you can have data with some cameras just one day in the year, so you cannot just see what are the trends, or you can have data from a camera, but you have artificial intelligence behind, and when they just count a certain number of cars, so you know that it's systematically underestimated. So how can we go over that? So we have plenty of questions like that for researchers. Yeah, temporal coverage is not the same, spatial coverage also. So for instance, we have a lot of data for highways, but not for streets in more residential areas. So there's a lack of data for that. As I said, telematic data are very, very expensive for the moment, and we're uncertain of the validity. So we don't really want to pay like $100,000, and if this data is not worth it. And there's a lot also of lags in these process. For instance, right now we're working on with the origin destination survey from 2013, because that's what the city owns right now, but it's 10 years old. The 2018, because it's once per 5 year, 2018 is not yet in their hands. So there's a lot of lags here. So that's the objective, and this carbon map project, it covers all the sector. I gave an example with road transportation, but we really wish to develop an open online tool. It's a kind of map that people will consult. They will see the emissions on the city. So the idea, of course, is to help decision makers, but also, as I said, and we have researchers in the team, which are like doing social marketing. So they try to understand how we should show this to make people change behavior, so that there's a science behind that. So if we show different trends or different pictures of what if you do that, that would give that, depending on how you present these things, you can have more or less behavior changes. So that there's also like plenty of research needs also on this side to make sure that this type of quantification tools really have their potential impact. Very quickly, because I was told to use 45 minutes. So we also work, that's another example with urban metabolisms. So the idea of that, and once again, there's a paper to look at, it's really to look at all the material and energy flows coming into a city. That's a consumer-based modeling. So that's an example of consumer-based. So you look at all the flows of material and energy coming in the city, and you apply environmental indicators to that based on life cycle assessment. And it's a dynamic prospective model. So for instance, you look at you have links between these flows and some parameters such as the population, and also you can enter some regulations, the effect of regulations. So then you can see how it evolves over time, and you can test. The idea is to test scenario. What if we implement this type of regulation? But since it's urban metabolisms with a consumer-based approach, you could test the implication of regulations that will lead to consumer behavior changes. So circular economy strategies, it is an example of things that we could test, and what would be the impact on GHG emissions, for instance. So I'll go very quickly, but for the moment on the model, these are the different sectors that have been modeled. And we also integrated the idea of social contagion, because behavior, and the example I'll show is that people who are eating vegetarian instead of meat diets, that's a lot a thing that can be modeled through social contagion, because like you meet people who eat more vegetarian and you say, okay, I'll try that. That could be a good way to decrease my emissions. So this is, we have implemented equations to show that also, and the effect of that. And just an example with the model, with the limitations now, because it's really the first version of the model. The impact, the carbon footprint of one person was 15 tons CO2 equivalent in 2018. So with the baseline, with the regulations that are already there, they are already planned, then in 2030, the carbon footprint was decreasing to 12.7. But then he looked at a social contagion phenomenon on this plant-based diet, of course, with some assumptions on the different parameters, but it was decreasing to 10.8. So it's just to give an idea of the different things that we could test in order to see what would be the impact. So last slide. So what are the different limitations of this approach? We want to add other indicators, and in the second version, we did that. So not just look at carbon footprint, but other types of environmental issues. Missing sectors also, so we don't have everything. So when we see 15 tons CO2, some of the things that we consume are missing. It's not there yet. We are going to refine data also. We find a lot of data at the federal level, because basically it's economic data, but it's very difficult to scale at the urban level. We make a lot of assumptions. So we could do a lot of research on that. Also, once again, we have emission factors that are current emission factors. We don't make them change in the future, but they will. We also, this has been done in the second version also, to refine spatialization. So to know, to tag where the material is coming from, so that you can see where emissions are occurring. Of course, make it more accessible in the future. And another idea is that we could model very different kinds of circular economy strategies. So that these were like very quickly 3 examples of research or tools that we developed, and all the different challenges associated with that, and like disciplines and people that could get involved in this type of project in order to make it work. So thank you very much, and I'm available for questions.